Okay, so page 71, compass directions. Make sure you have a ruler for these ones. I think if you have squiggly lines, you're going to have a squiggly answer, right? So you got to make sure. So a plane leaves Winnipeg, Manitoba towards Brandon, which is 132.8 miles due west. So that really means that you're starting from Winnipeg and you're going straight west. Okay? So if you want your interpretation, I'm going to sketch this scenario. If this is Winnipeg right here, Winnipeg, but we're going west, right? So this is your, in a sense, you have, as soon as it's compass directions, you have a compass rose on you, and this is west, right? So we're going straight west, that's what it's saying. We're headed to Brandon, which is due west. Does that make sense? Okay. So this is Brandon. And we're traveling 132.8 miles. So I always like the interpretation, like where it's like ugly, a bunch of stuff happening, and then have a clean version after, where you transfer information that pertains to the triangle over to the side. Next it says, once in Brandon, it picks up passengers and then heads west 63 north. So there's another compass direction given. So watch that one of the sides is actually running along the west-east line or the east-west line, right? So from here, we go west, we start west, but then we go 63 degrees north, okay? So this is the trajectory you're now taking. So the 63 needs to go there, okay? And then, so we drop off people at Russell. So this up here, I kind of ran into a bit of a problem there, a bit tight there, but it's gonna work. So that's Russell, to drop off passengers there. The town of Russell is 381.52 miles from Winnipeg as the crow flies. Have you ever heard of that term, as the crow flies? It means direct distance. If you could be a crow and go straight to where you wanted instead of going blocks this way, right? As the crow flies means direct distance. I will just add that, direct distance. So we know that if you could fly straight to Winnipeg from Russell, this stretch right here would be 381.52 miles. I actually figured all this out using Google Maps, okay? So this is my interpretation, and we have 0 angles inside the triangle right now, okay? But there's a couple things you can observe, maybe. I observed that there's a straight line here, the east-west line. So if this is 63, I could figure out the rest here. If you're missing that, you know that there's a 90 here. You can confidently say there's a 90 there. And you can also say that this, right, this other side is also 90. So we take that away from 90, so you got 27 there. So altogether, you have 90 and 27 in that corner. Does that make sense, Sean? Yeah. Please ask if there's something in particular. So this is my clean version of this scenario. So this is going to be 90 plus 27. Okay, so that's 117. Right there. That is worth a mark. Like if you coming up with the one angle that should come to the clean side, that's a one marker in my opinion. So it's R, Brandon, and Winnipeg. And what's so particular about this one is that you're actually traveling along the east-west line, or sometimes you're traveling on the north-south line. One of the reviews that I gave you has a scenario where you're going straight down south, right? So that is very important because it can help us find triangles, or angles, I should say. So this is 132.8 miles. This is 381.52 miles. We've got the sketching down, I think. We're okay there, Sean? Which part?
I got lost.
On the diagram, or? On B? D. Okay, okay. Yeah, I'll get there. So the solving part you were fine with? Okay, direct distance from Brandon to Russell. Let's do it anyways to review. So we've got a pair. So this must be done with sine law. Wait a minute, is this SSA? Is this SSA? You have a pair and you have a side. How come we didn't worry about it here? Because I made sure it worked. You had no idea of the issues of the SSA, but you could technically, if you flip this over, this would be the rod, and that'd be your string, and your string is longer than the rod, so you have it is possible. So I wouldn't do that to you unless you have a prompt asking you to figure out, is there a solution? Don't worry about it. So sine of 117 over 381.52. Sine of what can I do here? The only thing I can do right now is solve for angle R. So don't be going straight to what you want. You have to figure out the unknowns. Okay. So sine of R is 132.8 times sine of 117 divided by 381.52. I know I'm going a little fast, but you can slow me down later. Our sine inverse of this, which is 0.310 and something, so angle R is 18.01 degrees. Important, but not the final answer. We want angle W, and that's 180 minus 117 minus the one I just found, and that gives you 44.93. Also important, but not the final answer. Let's use cosine law, right? We've got this angle now here. 44.93 is this one. Side angle side. So I'm going to use cosine law to review cosine law and figure out this side right here. So side W squared would be 381.52 squared plus 132.8 squared minus 2 times 381.52 times 132.8 times cosine of 44.93. Did I use cosine law? I didn't. So I have to do this with you live on location. Okay, clear. I get 91,453.52 something. And then I take the square root of that. 302.41. Yes, it matches my answer. That means we're okay. Doesn't happen very often that I get it right, apparently. Okay, there you go. 302.41 is the direct distance between Russell and Brandon. Okay, so we've got B. C, it says, how much further north is Russell compared to Winnipeg? Okay, this one I need you to understand. I don't want you to just calculate that. So if compared to compared to Winnipeg, how much further north is Russell? Like it's asking for the height, right? Because this is Winnipeg here. How much further up north would you have to go to Russell? So it's asking for the height of this triangle, okay? Essentially. And so for C, the height is, you can grab this one and multiply it by sine of 117, or you can grab this slant, which touches this angle here, right? So this slant times sine of W. It's up to you. Both give you the same answer. I'm going to use W times sine of 117. That's 269.4 45 miles further north. So I'm asking for the height of the triangle. For D, if the plane returns back to Winnipeg, calculate how long a round trip it would take, or how long the round trip would take if an average speed of 180 miles per hour is reached. So you need to do total distance, right? Total traveled would be adding them all up, right? 132.8, 381.52, and 302.41, bless you. And you add them all up, all the three distances. So total is 816.73 miles. Okay, so that's what you traveled. And it's miles per hour, correct? So you could just say 180 miles in 1 hour. Therefore, 816.73 miles, how many hours would it take you? Okay, that's one way of doing it. Cross multiply and divide. So 816.73 times 1 divided by 180. And you get 4.54 hours. Does that make sense? All of I hope that answers it. Or was there something in particular? I could have asked for minutes. So if I do ask you for minutes, you just say this is 4 hours, and then just multiply the decimal by 60, right, to give me my minutes. So that's that. Are there any other questions from the booklet that you would like me to clarify, like in the booklet? No? Okay. So I will now switch over to the handouts. Okay, so I'm gonna ask you to number them, because I named the keys as well, but I also am gonna put a number on them, so you kind of know what's what. So the first one looks like this with the kite, except for you're not gonna do the kite. I'm gonna change this up a little bit. That way you get to practice the two solution thing that we just did today, the SSA with two solutions. So can you just cross out? My key has the same crossed out path, right? And then just copy this down. Consider triangle fun, right? Where angle F is equal to 51 degrees. Side U is 10.5 centimeters. Side F is 9.1 centimeters. I gave you a whole bunch of handouts, Supit. You should have it. Right? Just copy this down. That's it. And then solve for side N. And so you have the whole page to do it. Okay? Maybe I'll add justify how many solutions there are. Okay, so that's the only change that I make on this one. I call this number 1. Okay, this is review number 1. It is basically an old quiz, and I'm just changing that part up so you get to practice the SSA. The back is the same; it stays intact. If you just look at the back real quick, right? It has some compass direction questions. So it has 2 indeed, 2. So that's good practice. So that's number 1. Did you get that or what? Here, that's number 1. Number 2 is the tower one. Okay. So put a number 2 on the towers. I'm just going to show you real quick. Those are the towers. But you're going to make slight changes to it or else my key is not going to add up with yours. Okay, so I'm going to just change the angles real quick here. And I'll look at mine here so I get it right. You got this one right? Number 1 is done. You crossed off that question. You added this. So you have the whole front page to do that. Then we put that one away. This one is what we call number 2. And we're going to make changes to these angles. Okay? So instead of 16.5, you see up here 16.5, you're going to change that to just 6.5. So you're basically getting rid of that. It's just 6.5. Instead of the 15.8, it's going to be 5.8. There was a typo, so that's why I changed. Okay? That's the only thing you need to change there. Got it? So you basically get rid of the 1s. So it's 6.5, 5.8. That's it. I give you a diagram on this one. So sometimes I'll give you a little diagram that you need to fill in. So you just watch out for that one. The back side has the grandfather clock, which we have already talked about. Like it wasn't one of the examples in the booklet. So if you go look that one up, you can probably find it. There's another compass direction and another compass direction, so you can really practice those. Okay. Remember, angle of depression is always measured with respect to some sort of horizontal, right? So when I give you angle depression for a plane or something up there, please don't do this, right? Oh, plane sees the airport. This is my angle of depression. That's wrong. Angle of depression, right? Angle of depression goes there. Okay, so you got to make sure you get that right. You get to use alternate interior and bring it down, no problem. Okay. And so that's 1 and 2. I did make the changes there. I'm not sure. I want to give you a third one, but I don't want to overwhelm you either. This was another. It's just an AC with a bunch of sine, cosine law, and it's multiple choice. So if that interests you, it also has some word problems in the back with compass directions. So if you want that one, I'll just hand it out to you. You do whatever you want to do with it. You can always use it to review for the cumulative later on, right?